We're going to be working on 3.1 today. And first, we have to understand what a polynomial is. When is something a polynomial and when is it not? Any idea? Poly means many, nomial means number, many numbers. So we talk about monomials and binomials and trinomials. So a polynomial would be something like this. 4x to the fifth minus 6x to the fourth plus 2x to the third minus x plus 1. Okay? That's what a polynomial is, and maybe it's easier to talk about what a polynomial isn't. And it has everything to do with the variables. Okay? You are not allowed to have a negative variable, a negative exponent on a variable. Okay? You're not allowed to have a variable in the denominator. You're not allowed to have an exponent that is a fraction, or, sorry, a decimal, or a fraction. Yeah, you could have multiple variables, and I'm not really going to worry about that because everything we do in this class just has x's and y's. And you're also not allowed to have a variable inside a square root. Okay, all of those are not polynomials. The easiest definition is to say you have variables with whole number exponents, and then they're just added together. So 6x squared minus 3x to the first plus 8. What is the exponent on a variable if there's a constant? It's actually 0. So at the end of this polynomial, 1x to the 0. So anytime you see one of these other options where the exponent is not a whole number, or if you have a variable in the wrong place, those are not polynomials. Sometimes they'll try to confuse you and they'll say something like this. Is that a polynomial? All you look at are the variables. Is this okay? Yes. Is this okay? Yes. Is that okay? Yes, yes, and yes. Okay. Can you identify polynomials and non-polynomials? All right. Polynomials are classified by type according to how many terms there are. What is a term? A term is it's a number and a variable combined together. And sometimes you're missing the number and sometimes you're missing the variable. But up here, this would be a term, and this would be a term. That's a term, that's a term, and that's a term. So the terms are separated by addition and subtraction. So that one has 5 terms. The one below it has 1, 2, 3, 4. It also has 5 terms. Well, if it's multiplication, so if I had 5xy times 6x squared y to the third, then I can simplify it, right? And I would get 30 x to the third y to the fourth, and that becomes a single term. So that's a good point, is your terms need to be simplified in order to be counted. Because if I had 4x plus 3x plus 1, how many terms does that have? It really only has 2. So you do need to simplify before you count. That's a really good point. Okay, what do we call a polynomial that only has 1 term? Well, it is a polynomial, but specifically it's a monomial. Okay, what do we call a polynomial with 2 terms? Binomial. And 3 terms? That is a trinomial, and bigger than that, you could say quadrinomial, quintinomial, and so on. I don't really worry about it. Once you get past 3, I would just say 4 terms or 5 terms, 7 terms. Okay. The next thing is, well, so you can identify yes or no, is it a polynomial? If it is a polynomial, then it has a type. You just count the terms. Monomial, binomial, trinomial, or 4 terms, 5 terms, 6 terms, and so on. The next thing is the degree. And degree is actually really important. The degree is the largest exponent. So this one has a degree of 2. Okay? This one has a degree of 1. And when we organize polynomials, we always start with the largest exponents and then we go down from there, and we call that descending order. So if I had 6x plus 4x to the third minus 7x to the fourth plus 2x minus 4, let's rearrange this. Let's find the type and let's state the degree. What do I write first? This one, negative 7x to the fourth, and then plus 4x to the third. And now I don't have an x squared term, but I have 2 x terms, and they turn into plus 8x minus 4. That is now written in descending order. We started with the largest exponents, and we worked our way down. Now that we have it simplified, how many terms does it have? 4. And because, I guess that's a bad number, but 1, 2, 3, 4 terms. What's its degree? The largest exponent is a 4. Why do we care about the degree? Well, the degree tells you what type of graph you're looking at. Yeah, kind of. Even and odd comes into play. So let's say I had degree equal to 0. An example of that would be y equals 5. Is that a polynomial? Yes, it's y equals 5x to the 0. Does it break any of the polynomial rules? No. No negatives, no fractions, no decimals, no x's under square roots, no x's in the denominator. It works. The graph of that is simply a horizontal line. Okay. What would a degree 1 polynomial be? Give me an example of a polynomial that has degree 1. Y equals some x to the first. So 3x minus 4. Okay, that is a slanted line that looks like this. Okay, but what if I made the 3 negative? What would it look like? So if I had y equals negative 3x minus 4, then it's going to look like this. So if your line has any slant to it, then it is a degree 1 polynomial. It has an x. If your line doesn't have an x in the equation, then it's just a horizontal line at y equals whatever value it hits. Okay. What about a degree 2 polynomial? Any parabola. So what can parabolas look like? Well, that sort of parabola has a leading coefficient that is, so it could be something x squared plus something x plus something, right? If the parabola opens up, what do you know about this equation? The first one is positive. Does everybody understand that? Now we call the first coefficient, once you have reordered it, the leading coefficient. If the leading coefficient is positive, the parabola opens up. If the leading coefficient is negative, then the parabola will open down. Okay? What would a degree 3 polynomial look like? It would be an x to the third equation, and every x can represent a root. So you notice, in degree 0, I have no x's. How many times does that graph hit the x-axis? None. In a degree 1, I have x to the first. How many times do those graphs hit the x-axis? Once. Okay, degree 2, I have x squared equations. How many times do they hit the x-axis? Up to 2, right? Can it miss? Can a parabola miss the x-axis? Sure it can. Here's one. Can a parabola hit the x-axis once? Well, that's kind of tricky, but if we look there, we have 2 answers, and then 2 answers, 2 answers. What's happening to the answers? They're getting closer together until right there, it hits it once. So an x squared graph can hit the x-axis twice, or once, or none. What would an x to the third graph look like? It could hit 3 times. So if I have a positive x to the third, then the graph's going to look like this. Okay? What would a negative x to the third graph look like? It would start from the top, and it would come down and back up. Now, that might not be the correct graph. The graph might actually look like that, and it only hits once. Or, if I bring it down, it could hit twice, or it could hit 3 times. So the degree tells you how many times it could hit. So an x to the third could have 3 x-intercepts, or 2, or 1. Can it have none? Can an x to the third graph miss the x-axis? There's no way. Yes? No, the degree is the highest exponent, the first one. Once you put it in order, it's the first one. All right? What about degree equals 4? What is that going to look like? It could be a W. So it could look like this. I could have 4 answers. Is it possible to get 3? Well, if I move this up, now it has 3. Is it possible to get 2? Now it has 2. Is it possible to get 1? Now it has 1. Can you get none? That would be none. So up to 4. And any number below that, depending on how you draw it, or what the equation is. Okay. This would be a positive x to the fourth graph. What would a negative x to the fourth graph be? So we would start this way. Okay. What about degree equaling 5? If I have a positive x to the fifth, where am I going to start? I'm going to start on the bottom. And then I go 1, 2, 3, 4, 5. It could have 5 answers, or 4, or 3, or 2, or 1, or can it have none? No. So if I bring this up, is there any way to miss entirely? No. So, do you see any patterns here? What do you notice? So, the degree will tell you how many times it can hit, or any number below that, unless what? Unless what? Unless it's odd, and then you can only go down to 1. Do you notice any other patterns? Could we group these into 2 different sets? Now, let's forget about this one, right? That one doesn't really come into play. What do you notice about the others? In the odd-degreed polynomials, the endpoints are going in different directions. So for every odd polynomial, you might get left side down, right side up. Or if it's negative, then it would be left side up, right side down. Can you remember that? This is a positive slope, right? So if I had an x, like a 2x, that would have a positive slope. So positive starts low and ends high, and negative starts high and ends low. What about the evens? They're either both up or both down. So if we skipped way ahead, and I said I had 5x to the 11th with a whole bunch of other stuff there that I don't really care about at the moment, what do I know about that graph? It can hit the x-axis up to 11 times. What else do I know? Starts down and ends up. So it could look like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? Or, the weird thing is, it might actually just do this. Right? It might not have a bunch of turns in there. In fact, if you graphed x to the 11th in your calculator, it would look like this. It looks like an x to the 3rd graph that has been stretched a lot, and it only has one root. Okay? But what we're worried about is the end behavior. Where does it start and where does it end? And here's how we write that. We say, as x approaches negative infinity, then f of x, or in some cases they put y, approaches what? So what it's saying is, if you start in the middle of the graph and you move the x's towards negative infinity, so this way, which direction is the graph traveling? As the x's go to the left, is the graph going up or down? Down toward what number? Negative infinity. So the answer to both of these would be negative infinity. And as x approaches infinity, f of x, or y, I can't remember what the book does, approaches positive infinity. And that is called end behavior. And we write it in limit form, which is something you'll see in calculus a lot. As x approaches infinity, f of x approaches infinity. Translated into English, it means when you go right, the graph is moving up. So if I wanted to translate that, I just say, as the graph goes right, it also goes up. As the graph goes left, the graph goes down. Okay? So, what type of polynomial is that? Trinomial has 3 terms. What is the degree? 5. What is the end behavior? Well, without drawing it, as x approaches negative infinity, y approaches... Ooh, it's a tough one. Maybe we should graph it. What do I know about this graph? It's negative and it's also odd. So we're going to start... Are we going to start high or low? We're going to start high. How come? It's odd, which means it has a negative slope. So it looks like this. High left side, low right side. So we come down, and I don't know what happens in the middle, right? But I know that it's going to end high, or start high, and it's going to end low. What could happen in there? Well, it might have 1, 2, 3, 4, 5 roots, or it might do something like this, or it might do something like this. We're not sure. But we know that the left side goes up and the right side goes down. So mathematically, as x approaches negative infinity, the y value approaches positive infinity. Basically, as the graph goes left, it's moving up. And then as x approaches infinity, y approaches negative infinity. So this says left and up, right and down. Okay? So let's do okay. What type of polynomial is this? 5 terms, which I guess would be a quintinomial, but we never say that. We just say 5 terms. What is the degree? Ooh, 4. It's not in order. I wrote it out of order. The degree is 4. What is the end behavior? So as x approaches negative infinity, x or y approaches negative infinity, and as x approaches infinity, y approaches negative infinity, because this is even, so the two tails are in the same direction, and the leading coefficient is negative, which means it's an upside down parabola. It's not a parabola anymore. So we know that the end is like this. We have no idea what's going to happen in the middle. It could be that. It could be this. What else could it do? It could be a W and hit 4 times. We're not sure. But we know that the end behavior is left, down, right, down. Does that make sense? All right, let's see if that covers everything we need to talk about. All right, 3.1. All right, 3.1. Yes or no if it's a polynomial. If it is, write it in standard form, state the degree, type, and leading coefficient. What is the leading coefficient in this one that I just wrote? -6, because it needs to be reordered, and the leading coefficient is the first one. Yes. So it says, if it's a polynomial, write it in standard form. That means reorder. So standard form is descending order. So all of those numbers, the -4, the -6, 2, 3, and 1, those are all coefficients, but the leading coefficient determines up or down. Right? It determines kind of like the slope. Okay, 11 through 15, it says evaluate. So if I said, what is, let's say this is f of x, what is f of -1? How would I find that? Substitute -1 everywhere there's an x, and I highly recommend, if you're plugging in fractions or negatives, that you always put it in parentheses. If you're dealing with fractions or negatives and you're substituting, always use parentheses. Yes. It would. If it's a whole number, you could graph it and then use table. Or you can graph it and push trace and just type the number in. So let's see if I have a graph already. I do. So here's this graph here, and I want to know what happens when x equals, in this case, 150. I can go to table, and I could scroll down until I got to the number I wanted, or you just push trace, and you can type in numbers. 150, and it will tell you the y value, or 8, and you can just keep plugging in numbers if you do it that way. And the nice thing about that is you can plug in decimals, 2.14154, and it will still give you the answer. So that'll always work. If you do that, you better make a note that says you did it, right? So I don't look at your paper and say, oh, wait, there's no work here. You don't solve it. Oh, If you're plugging in the number, you substitute and then simplify. Yeah. That's okay. Yeah, that's fine. Okay, 17, 18, 19, and 20 says describe the end behavior. So you're going to say as x approaches negative infinity, y approaches whatever. I do want to see if you can figure this out. Let's say this was our graph. As x approaches negative infinity, y approaches, so as we go left, the graph goes down. As x approaches infinity, whoa, that was terrible, y approaches 0. That's kind of weird, right? So the further right I go, the closer I get to 0. And that will never happen with polynomials, but it will happen with other things. What about this? As x goes to the right, y approaches any number between 1 and negative 1. So this actually doesn't have an answer because the further right I go, I can be anywhere between negative 1 and 1. It doesn't approach anything. It just oscillates forever. Well, it would be no number. Okay, what if I had this? As x goes to the left, y approaches, so we're going to turn, it's any number between infinity and negative infinity, so this doesn't exist. But as x approaches infinity, y approaches 0. The further out I go, the closer and closer I'm going to get to 0, even though I hit 0 a whole bunch of times. Right? I keep hitting 0 over and over and over, but the further to the right I go, the closer and closer I get to that y-axis. And eventually I'll be so close to the y-axis I won't be able to tell the difference. Okay? All right. And then 25 through 32, you're going to type in the function and graph it. How do they want you? Hang on just a second. So they talk about example 4. I'm not going to make you do those. Okay, let's do 3 through, so this is 3.1, 3 through 21 odd. And then, oh, wait, never mind. Let's do 23, sorry. 3 through 23 odd. And I'm going to skip that whole section. And then let's do 33 to 43 odd. All right. Get to work.